Hello students, in this video we are going to be starting with associative property. Observe the following examples. Consider the integers -3, -2 and -5. Look at -5 plus -3 plus -2 and -5 plus -3 plus -2. So the difference between these two is the grouping of integers. In the first case, we have -5 separate. As you can see here, -5 is the value given to A. So it is denoted by A plus the grouping of B plus C. In the second case, we have A plus B, that is -5 and -3 grouped together, and then C is separate. Do you think these two are same? Do you think the grouping matters? Let us find out. In the first sum, -3 and -2 are grouped together, and in the second, -5 and -3 are grouped together. We will check whether we get different results. So, for -5 plus of -3 -2, what we need to do is we need to calculate the sum of -3 and -2. According to the 4 rules that we have learned, this is equal to -5. When you add this to -5, we need to start at -5 and move 5 times to the left. So we will end up at -10. Next, if we group -5 and -3, that is A and B together first, then we need to start at 0 and we need to move 8 times to the left. Then we'll end up at -8. Then we need to add the -2 and thus we'll end up at -10. Okay. In both cases we get -10. Similarly, if you do the following examples, you will find out that the grouping of the integers does not matter. Okay. So the grouping of the integers does not matter and you'll get the same result regardless of how the integers are grouped. Take 5 more such examples. You will not find any example for which the sum is different. In general, for any integers A, B and C, we can say that A plus B plus C is equal to A plus B plus C. So whenever you are trying to say the brackets out loud, you can say it like A plus, then give a pause and then say B plus C. Okay, so that indicates that B and C are grouped together. For this one, you say A plus B plus C. Okay, so using the pause, you can clearly denote where the grouping is present. So addition is associative for integers. Associative means that whenever there is addition of more than 2 integers, the grouping does not matter. Okay, in commutation we have learned that the order does not matter. Okay, here we are learning that the grouping of the integers does not matter, you will get the same results. Next, we will start about the additive identity property. When we add 0 to any whole number, we get the same whole number. 0 is an additive identity for whole numbers. So what does an additive identity mean? An additive identity for any set is when you take any member of the set, add it to the additive identity, the number should remain the same. Okay, so for whole numbers, if you take any whole number and you add 0 to it, you will get the same whole number. For example, you take 3. 3 is a whole number. You add 0 to it and you will get the same whole number, that is 3. In this case, we say that 0 is the additive identity for the set of whole numbers. This means that under addition, 0 preserves the identity of the whole number that it is being added to. Okay. Is it an additive identity for integers also? Do you think 0 is the additive identity for integers also? So what this question means is, if you add 0 to any integer, Do you think the integer will remain the same without changing? Does it preserve its identity? If you take a look at all these examples, you will find that 0 is the additive identity for integers. This is because even when you add 0 to a positive or negative integer, you will get the same integer. Okay? So here we have minus 8 plus 0 and the result is minus 8. Okay? So given that 0 is the additive identity for whole numbers and for negative integers as well, we can conclude that 0 is the additive identity for the entire set of integers. Okay? You can verify it by adding 0 to any other 5 integers. So in general, we can say that a plus 0 is equal to a is equal to 0 plus a. So they have also highlighted the commutative property here, where a plus 0 is equal to 0 plus a, where the order does not matter. Okay, so 0 is the additive identity for integers. Next, write a pair of integers whose sum gives a negative integer. Okay, so you want a negative integer as the result. Okay, so I'll just solve them one by one here so you can see it better. So 1.a, you want two integers whose sum gives you a negative integer. Okay, so for our example, let us take two negative integers. Okay, so let a be equal to minus 3 and let b be equal to minus 2. So a plus b is equal to minus 3 plus minus 2 and the answer is minus 5. If you are confused about how this happens, how the sum of two negative integers gives you a negative integer, I will give a link to a separate explanation in the description box below. You can refer to that. So the next question is an integer smaller than both the integers. Okay. Okay, that is question C. But let us solve this first and then go to B. So an integer that is smaller than both the integers. To solve this, let us refer to our number line. So we know that in our number line, as you keep moving to the left, the value of the numbers keeps on decreasing. So the more left you move, the smaller the numbers get. Okay. So the question is, you need to find two integers whose sum will give you a smaller integer. So you can think about it this way. How can you get a smaller integer when you're adding two integers? It is when you're adding two negative integers. Okay. We know that in our number line, the farther to our left we move, the smaller the integers get. Okay. So we need to find a situation where we are adding the sum, that is, we are finding the sum of two integers, but the result is less than either of the integer. So this is possible in the case where we are adding two negative integers. So for our examples, we can take the two negative integers to be minus 4 and minus 3. Okay, so minus 4 is present here. If you have to add minus 3 to it, you need to move 3 times to the left and thus you're going to end up at minus 7. So the value of minus 7 is actually smaller than both minus 3 and minus 4 because it is present farther to the left of the number line. Okay, so to get an intuitive understanding behind this, you can take this situation to represent a case where first you have borrowed 4 rupees from your friend. Okay, after that you again borrow 3 rupees from your friend. So that means you now owe them 7 rupees. Just because the value 7 is greater than both 4 and 3, it doesn't mean that minus 7 is also greater than 4 and 3. When you have a debt of 7 rupees, that is, when you have minus 7 rupees with you, it means that your net worth is lesser than the situation where you had minus 4 or minus 3 rupees. Okay? So for number C, you can use that example where the sum of the pair of integers gives you an integer that is smaller than both the integers. Now let us try to solve question B, where they want us to find integers whose sum is equal to 0. So a very easy example for this is 0 plus 0 is equal to 0. You can take both A and B to be equal to 0. In that situation, the sum is definitely 0. However, in a situation where you are taking a non-zero integer, when would their sum be equal to 0? So for example, you take any integer A and you're adding something to it. Okay, I'll just put a dash here. You want the sum to be equal to 0. When you think about it, you will realize that whatever you need to add should be equal to the value but opposite in the sign. Only then these two will cancel each other out and you will get the total sum to be equal to 0. So take any integer, for example, say A is equal to 10. Then you need to add minus 10 to it so that you will get 0. A does not necessarily have to be a positive integer. It can also be minus 6. It can also be any negative integer. In that case, you need to add the negative of the negative of minus 6, that is plus 6. Okay? In that situation, you will also get 0. So for this situation, A is equal to minus 6. That means that minus A will be equal to minus of minus 6 and you'll get plus 6 as the result. Therefore, the answer is 0. For the next one, we have to let us solve D. Okay, so we need to find an integer we need to find two integers whose sum is an integer smaller than only one of the integers. Okay. So we need to find an integer whose sum is smaller than only one of the integers. To solve questions like this, you can also use a bit of trial and error. You can play around with the numbers to see if the result and the number satisfy the given constraints. So let us start with the number 5. Okay, so we are starting with the number 5. And if we add anything, so this is actually plus 5. So if we add anything positive to this number, we know that we'll get a result that is greater than 5 and even the number that we are adding to it. So for example, if you're adding 2, you'll get 7. Okay, so let me zoom this here a bit. Okay, so this will give us a positive number that is greater than both 5 and 2. So we know that we cannot have a sum of two positive numbers. Instead, we will try to make this a negative number. So in this case, the answer is not plus 7. For this case, you have to move to the left of 5 2 times. So you'll get plus 3. Now let us see if this satisfies the condition that we have been given with. So the condition is we need to have an integer that is smaller than only one of the integers. Okay, so here we have plus 3 as the sum of these two integers. Plus 3, is it smaller than plus? Yes, it is smaller than plus 5. Is plus 3 smaller than minus 2? Definitely not. Minus 2 is a negative integer and plus 3 is a positive integer. Therefore, plus 3 is greater than minus 2. So this is a correct example for this case where the sum is an integer smaller than only one of the integers. So you can play around and get this result. Okay, So for D, we have A is equal to plus 5 and B is equal to minus 2. Now, let us go to question number 1E. So the question is, we have to find two integers whose sum is an integer that is greater than both the integers. So the sum needs to be greater than both the integers. So this is a rather easy question. So any two positive integers you take, their sum will definitely be greater than both of them. Okay, this is because when you're adding two positive numbers, you will always move farther to the right of both of them. Okay, so you can take any two positive integers and you will get that the sum is greater than either of those two. For my example, I'll just take what I explained in the previous example, that is plus 5 and plus 2, and the result is going to be plus 7. So here we have A is equal to plus 5 and B is equal to plus 2. Let us move on to the next question. I will just clean this up a little bit so we can solve the question 2 right here. So the question A in question 2, that is 2A, wants us to write a pair of integers whose difference, okay, so whose difference gives us a negative integer. You can think about this a little bit, but the easiest example in this case is to work with two positive integers such that you are subtracting a bigger number from a smaller number. Okay, so let us have our first integer to be plus 2. Okay, let us subtract something that is bigger than plus 2. That is, let us subtract plus 6. In this case, our answer is going to be minus 4. Okay, so using the laws or using the rules that we have to subtract a positive integer from another positive integer, we will end up with minus 4. Okay, so this is a very common situation where we are subtracting two numbers, that is where we are finding the difference of two numbers and the result is a negative integer. Next, we need to find two numbers whose difference is 0. Okay, so 2.B needs us to find two numbers whose difference is 0. So let the first number be equal to A and we are subtracting something from it. Here I'll just put a dash. Okay, so we're subtracting something from it such that the difference is 0. Okay, so let me just separate the previous question from this question. So what is it that we are subtracting such that the difference is 0? You have to subtract the same thing such that the difference is 0. So A minus itself is going to give you 0, correct? So you can substitute A with any integer, positive or negative. You're going to end up with the answer as 0. For example, I'll just continue the same problem here. So for example, let A be equal to plus 10 and we are subtracting plus 10 from itself. So this is actually the equivalent of plus 10 minus 10. Okay, so this is going to give us a 0. Or we can also have the situation where A is equal to a negative integer, that is minus 7, and then we are subtracting minus 7 from itself. Okay, in this situation, this is going to be actually equal to minus 7. Minus of minus is going to give us plus. So minus 7 plus 7, this is going to end up with 0. Okay. Next, to see, we need to find an integer. We need to find a pair of integers whose difference is an integer smaller than both the integers. Okay. So the difference need to be an integer that is smaller than both the integers. So for this one, it is also a very simple problem. We need to just pick two integers that are very close to each other. Okay, so let us play around a little bit. Let us pick two integers, both of them positive. I'll give you a sort of a thumb rule here. Whenever you're trying to find two integers whose sum or difference satisfies a given rule or constraint, try to work with positive integers first. Before you try to add negative integers to the mix, try to get the result using positive integers. If you cannot achieve that, then you will know why and where you cannot achieve it. And in that case, you can substitute a negative integer and try. This is when you are doing trial and error. So let us try to solve 2c using two positive integers. Let us keep the positive integers to be plus 7 and plus 6. So these two are very close to each other. They are right next to each other on the integer number line. Okay. So the difference between plus 7 and plus 6 is actually equal to plus 1. So this actually satisfies our rule. So the integer plus 7 is also greater than plus 1. And even plus 6 is greater than plus 1. So we have found the pair of integers whose difference is smaller than both the integers. Okay, so this satisfies our given rule. Now, let us move on to 2D. I'll just draw a line so we can differentiate between the different problems here. So 2D, we need to find a pair of integers whose difference is greater than only one of the integers. Okay, so the difference is greater than only one of the integers. Now you can think about this problem a little bit. Okay, to solve that, again, let us take two positive integers only first to try if we can get a solution. So let us take plus 7, okay? And we need to find another integer such that we have the difference to be greater than only one of the integers. In this case, I'll just give you the answer over here. So if we subtract 3 from plus 7, you will get the answer to be equal to 4. So let us see if this satisfies the condition that we have been given. So 4 is greater than 3, but it is not greater than 7. Okay, so it does satisfy the condition where the difference is greater than only one of the integers. So you can imagine taking the 7 and splitting it in such a way that one of the sides is bigger than the other. Here you have split it into 4 and 3. And you are subtracting 3 from 7. So you will definitely get 4 where it is greater than only 3, but it is not greater than 7. So I want to take this problem as a chance to remind you all of the basics of subtraction. So we have two numbers on the left hand side of the equation. They are plus 7 and plus 3. Plus 7 is called as the minuend. So the number from which you are subtracting another number is called as the minuend, and 3 is called as the subtrahend. So the number which you are taking away is called as the subtrahend. Okay, so you can remember these terminologies using this very easy rule. So we have our minus sign here, and whatever comes before the minus sign can be remembered as the minuend because minu comes first in minus, and whatever comes after the minus sign can be called as the subtrahend. So these are just names given to both of these numbers. Okay, so for our example, we had to find two integers whose difference is greater than only one of those two integers. So we could find 7 and 3 whose difference was 4, which was greater than only 3 but not greater than 7. However, for the same set of three numbers, if we solve them like this way, like if we replaced the difference with the minuend and if we with the subtrahend, and if we made 4 to be the subtrahend, then this would not have been the solution to that problem. This is because 3 is less than both the minuend and subtrahend. Okay, so the question was to find the difference that is less than only one, either the minuend or subtrahend. Okay, so even though we are splitting 7 as 4 and 3, one of these two does not satisfy the given problem. You have to find two integers such that their difference is greater than both the integers. This is a tricky problem. You should think about it. If you need time, you can pause the video. So the most simple example I can think of, to find this example, you need to know the rule where minus of minus is equal to plus. Okay, so that rule you need to understand very well. If you need more time to understand it, I'll just give the link to that video in the description box below. But for this case, I will show you a sort of trick you can use. Let us take one of our integers to be 0. So you should always remember that 0 is also an integer and you can take it as one of the two integers. And next, let us take, so to find the difference, you're subtracting it, and let us take minus 1 to be the other integer. In this case, the answer is going to be plus 1. That is because minus of minus is equal to plus. Okay, so minus 1 is also less than plus 1 and 0 is also less than plus 1. Therefore, we have found two integers such that their difference is an integer that is greater than both of them. So this is one of the possible solutions to 2e. So that is the end of this video. I will see you all in the next video where we'll continue with our lesson integers.